Welcome everyone to the NSX feature deep dive. My name is Catherine and this is Nick. Today we'll be giving you a quick overview of the various features in NSX, the architecture behind the network virtualization platform, and show you some cool demos. So network virtualization starts off with a core foundation of the vSphere hypervisor, and today we will be focusing on just the features that are currently shipping. We will not be talking about futures today. All right. So with the core hypervisor, we've taken all of the network and security functionality and embedded it directly into the hypervisor itself. This basically forms a core building block for us to scale out our network and security capacity as you're rolling out new hypervisors to support your applications. And this then delivers better throughput rates as you're trying to add in more network and firewall capacity. With this in mind, we can actually build up the network virtualization platform that abstracts away the underlying hardware underneath us. So you can continue to use the exact same network hardware that you currently use today. On top of this network hypervisor, you can basically think of it as conceptually very similar to server virtualization, which abstracts away the compute. So on top of this, we can actually form virtualized networks in a fully isolated manner and programmatically create virtual networks on demand and connect our virtual machines to them. So as part of this process, we'll be talking through a lot of the various features of NSX, starting with our switching, routing, and security functionality, and then show you a couple quick demos to support this. So these are all tools within your toolbox to get ready with NSX as you embark on this digital transformation journey. So regardless of what sort of use case you want to start off with, whether it's a very urgent security audit that you're trying to pass, or an IT automation project, or maybe you're looking at delivering more application continuity for your services, you can treat NSX as that core building block, that core platform to support all of your business needs. So whether you're like Vallejo Sanitation Department, who is trying to provide secure network access to the remote mobile workforce, who is accessing data center resources through their mobile devices and virtual desktops, starting off with that secure end user type use case. Or maybe you're more like a service provider, trying to build up a multi-tenant infrastructure and deliver security services and network services to your end clients, someone like Armor did within the last couple of years. Or maybe you're more like Bay State Health, who is trying to ensure that their hospitals had maximum uptime to deliver on patient care. They're basically trying to take 3 different data centers and pool them as one central set of network and security capacity and operate it as one big data center. So regardless of where you want to start, NSX is that core building block and core building platform to enable all of these use cases. So before we dive deeper into how these features work to support each one of these use cases, let me turn it over to Nick, who will give us a quick overview of the architectural components of NSX.
Thank you, Catherine. How many folks in the room, I'm just curious, are network operators, network admins, et cetera? Okay. So you guys are obviously here to learn about NSX. My goal in the next couple of slides in the next few minutes is to talk about those architectural components. This is a pretty busy slide, but the idea behind it, or the point that I want everybody to walk away with, if you're familiar, and I know a lot of you aren't coming from a networking background, but if you're familiar with a lot of the components that make up a physical network, the architecture that makes up a physical network, right? Not just the physical switches, but the data plane, the control plane, the management plane, whether that's done through some sort of CLI, whether that's done through some sort of graphical user interface, et cetera. The point of this slide is to basically say or articulate the fact that NSX essentially makes up or is comprised of those same components that exist in your physical network. Obviously, we're building a logical network or a virtual network on top, and we'll talk about that as we move through the slides. But the point here is just to make sure you understand, right, all of those things that apply in the physical world still apply and are relevant and are part of the NSX architecture. So in the next couple slides, we're going to go through each one of these specifically and talk a little bit more in depth about them. The first piece is the data plane, right? So how do we get packets from point A to point B? We'll look at a few animated slides later on in the presentation about how we actually do packet forwarding. But the pertinent parts here, are the fact that, again, we're taking your ESX or vSphere clusters and essentially installing hypervisor modules in them and allowing us to build logical networks. So the components that sit or represent the parts of NSX, whether that's logical routers, logical switches, firewalls, et cetera, and we'll continue to talk about those services as we go through the presentation, essentially exist and live in a distributed manner across your compute clusters, right? There's a couple other things to note in terms of how we do integration with the outside world, how we get packets in and out of the virtual network into the physical, et cetera. I'm not going to spend a lot of time on that today, just because we only have 60 minutes. But we do support what we call hardware VTEP, or the ability to basically integrate our overlay network in or support with certain vendors' hardware as sort of the gateway or route out to the outside world. The next piece is the control plane. In NSX, much like any sort of modern distributed system, we run 3 controllers that represent or make up our control plane. Obviously, there's 3 there for fault tolerance, high availability, redundancy, et cetera. If one goes offline, you still have the availability of having multiple controllers in your infrastructure. But again, those controllers, those NSX controllers, are deployed again in the vSphere clusters themselves. So the actual physical ESX nodes not only run the actual functions, the routers, the switches, the firewalls, et cetera, but also are there and run the actual controller nodes themselves as well. From a management perspective, again, I know not many of you raised your hand when I asked if you come from a networking administrator or operations background, but typically speaking, we find most network admins have the tendency to prefer a CLI-based way of managing their environment. NSX is no different. In fact, I would argue it's slightly different in the fact that we have this thing we call a central CLI, and the ability to sort of have all the distributed functions managed through one central location, as opposed to anybody who's familiar with managing a physical network. Typically, that's done on a very box-by-box basis. So XYZ vendors switch or router. I have 2 of them in my core, maybe 4 at my distribution, and 6 across my access layer. Each one of them represents a disparate management point, and therefore each one of them has their own configuration file that has to be managed independently of one another. In our world, while we do support the CLI and the central CLI function, we also have a GUI tool as well through the vSphere client that most of you are probably familiar with, that allows us to manage NSX as well from a management plane perspective. And a lot of the demos that we're going to go through today will show that GUI representation from the vSphere client. Again, the architectural components at a very high level is what we just went through. What I wanted to step through before we jump into any demos and actually show some of the features of the platform is just a quick sort of workflow on how we may actually set up NSX in our environment, right? So this is just a quick 5-step process of how we would actually set up NSX. The first thing to do is actually deploy that manager, right? So we deploy a virtual machine that represents NSX manager. And again, you give it an IP address, you can access the IP address through a web browser, and you're able to manage the environment. The next thing you do is essentially register that NSX manager to your vCenter. Right? So it's basically open communications between your NSX manager and your vCenter, and then the 2 are able to share information, share attributes. We're able to get information from your ESX nodes, or I should say the vCenter that represents all your ESX clusters, into NSX manager and start to understand what's happening within the environment. The third step is to basically go ahead and deploy those controllers. So again, that cluster of 3 that I mentioned before, we'll just quickly deploy 3 controllers on the ESX nodes themselves, and those will obviously be managed from the manager's perspective. The 4th step is basically what I'm summarizing as preparing your host, but technically what we're doing is basically installing the VIBs and installing all the DVS kernel modules on all of the ESX nodes that are in your clusters, allowing them to basically act as logical switches, logical routers, firewalls, et cetera. So the host prep piece here is basically done from the manager, and you're able to basically automatically load that software on your ESX nodes. So for example, if you wanted to take advantage of NSX on a particular cluster in your environment, that software would be there ready for you to take advantage of, and you wouldn't have to go through the installation process to set up those nodes prior to wanting to actually leverage or use NSX. And then the last piece is to essentially deploy what we call our Edge Services Gateway. The Edge Services Gateway actually comprises of multiple different network functions. But suffice to say, for our 5-step easy process here, what we're talking about is basically deploying a virtual machine in the environment that acts as sort of the gateway for in and out connectivity. So we've created this virtual environment, we've created this virtual network stack on top of it now. That network stack has to communicate with the external network. Again, any physical network, we don't care necessarily vendor specific or OS specific. But we deploy this virtual machine. Again, that virtual machine will represent a lot of different network functions, which we'll talk about in a subsequent section. But for this, it's suffice to say, we're basically deploying that as a way to get in and out of the particular NSX network. So in terms of setting up, again, that was just a high level of how you could quickly deploy NSX in 5 easy steps. In terms of actually deploying NSX, this slide, or what I would take away from this slide, is basically to say you have a number of steps that you do once, and then there's a number of steps that can be done repeatedly. So the blue stuff on the left-hand side of the screen are basically the things that we've done once, and some of those steps you saw on the previous slide. So that's basically prepping, if you will, the environment for NSX to run. The right-hand side is essentially what we would do on a continual basis based on, let's say, application requirements. So for an example, we're going to talk about a use case shortly around automation, where we're basically automating all the logical switching, logical routing components of a particular application. So if my app admin has a profile of his application and knows how everything is supposed to work, every time we want to spin up a new instance or a new version of that application, or a particular, let's say we want to move that application from dev to prod, we would likely spin up a brand new logical switch, a logical router, and potentially some new firewall policies as we sort of progress that application in the application lifecycle. So we'll look into that shortly, how that consumption piece works. But the important piece here to know is that we have a number of steps that we only do once, and then a number of steps that we do on a continual basis. Catherine?
So now that Nick's kind of installed NSX and gotten it configured, we're ready to get started with our first use case of how do we actually more secure our data center. So the reality of our investments today is we're putting a lot of time, a lot of effort into configuring our perimeter firewalls. And modern attacks are getting more and more sophisticated, where they're going either bypassing that firewall or going after our low priority systems. Now, how many of you still have Windows 2003 somewhere in your data center and are actually okay to admit it, right? Now, wouldn't it be great if we could identify those workloads and actually start to micro-segment those out at the lowest granularity of our network, actually putting it on a per VNet basis as if we had one firewall per virtual machine. Take all of those, instead of taking those Windows 2003 workloads and moving them off to a separate network, actually putting and bringing the firewalls to them, right? So if we could actually get that done, then we can actually more securely protect our data center from any attacks that are going after those low priority workloads. So let me tell you a little bit about some of the features to actually get started with that particular use case. So the very first thing that you'll need to do is actually get visibility into what's actually happening in your data center. And this is part of the microsegmentation planning and design process. So we actually will walk through 2 tools here called Endpoint Monitoring and NSX Application Rule Manager. These will be tools that will help you actually start to develop what your firewall policies are, identity firewalling, security policies, and actually doing some monitoring around that. So for the first endpoint monitoring, basically what we're looking at is everything that's happening within the guest. So I want to be able to know what are all the files running in this virtual machine, what are all the processes, and what are all the socket connections incoming and outgoing through that. right? So if you trust your application owners to tell you exactly what's going on, then great. If you don't have that information at hand, then you can start to run these tools to actually give you a little bit more visibility so that when you get started with microsegmentation, you're not inadvertently preventing that application from working properly. The second tool that we'll walk through is Application Rule Manager. This is a process by which you can start to analyze raw flows and actually start to create the necessary security groups as well as the firewall rules in order to develop that microsegmentation policy. So it leverages the core flow monitoring capabilities, and we'll then go through an analysis phase. You actually pause at that point and actually show it back to your security administration team, do some validations and say, like, are these really the firewall rules we want to be creating before you actually roll out that microsegment? So let's actually take a quick look into how these tools look within NSX. So the demo that I'll be showing to you today is how we would microsegment a 3-tier WordPress application. Now, on our NSX blog, we actually worked with a customer that was analyzing a more complex application. They were doing a microsegmentation project around an electronic health records application. They're analyzing over 2,000 raw flows, and from there, they spent maybe about 20 minutes going from no microsegmentation to a complete microsegmented electronic health records application. But since we can't sit through a 20-minute demo, I'll go through this 3-minute demo of a WordPress application. So first and foremost, we'll kind of log into the NSX UI. We'll go under Tools, Endpoint Monitoring. And from here, we can actually start to either look at some historical sessions that we've done or actually initiate a new session to take a look at our applications. So here I've got 4 VMs running, about 9 processes generating traffic, and then some classification of flows that are within this security group or going external to that security group, right? I'm going to dive a little bit deeper to understand VM to VM communications as well as what's actually running within that virtual machine. So here, let me just double click onto one of the Windows 7 machines, and I can either click on the arrow here and actually look at what's going on between these 2 particular VMs, all the processes and what ports and protocols are initiating traffic over. I can also look at all the outbound flows originating from this virtual machine. So you can actually trace it down to that VM. I can then double click into that specific VM and see all the different processes that are running on it, the version numbers, and exactly how many flows per application. Let's switch over to a process-based view. So across any of our virtual machines, show me all the different processes, what versions those processes are running, just to see if I have anything that is not out of date. From here, I can also do some filters and searches, so I can actually see if there's anything that I actually need to take a deeper look into, making sure that everything is okay. So again, this is based upon VM tools running inside of your virtual machines, as well as a guest introspection VM that's running on that particular host as part of that installation and deployment process. Let's switch over into the Application Rule Manager. Now that we understand what's happening within the guest, let's take a look on the wire. So again, we're going under Tools and Flow Monitoring. Application Rule Manager is just leveraging on top and analyzing raw flows. We can go ahead and initiate a new session. For this, it's my WordPress application, so I'm going to say my production WordPress version 3. I'm going to select those virtual machines that comprise my WordPress application. I'm going to sort this by name, and I've got it named by WP for WordPress, my database, my proxy, and my web servers. Right? We can run up to about, let's say I can choose a subset of maybe 20 VMs as part of this application, start to run a session, and then over time, we'll start to collect all these raw flows. Now you'll see this IP to IP and then some raw services. Now, I as a person don't speak in terms of IP, so I want this to actually be translated over into a VM name that I can understand and start to do more processing on. So I've clicked on the Analyze button that's automatically converted those or translated those for me. For any of these services, I'll also translate and say, okay, TCP/80, let me select over here HTTP. I can either create a new service or select one of these existing services, and that's basically converted that for me. From here, we'll actually show you any blocked flows as well as any allowed flows, and then you can start to create your firewall rules from this pane of glass. So here I'm just basically saying from external to my proxy, we'll create a firewall rule to allow that, between my proxy to my web, and then from my web or app to my database tier, I'm going to allow these pieces of traffic. At that point, you can actually, we're kind of in the staging area. We actually haven't published out the rules just yet. So this is a good time for you to pause, show that back over to your security team or back to your application team, bring all these teams together into one conversation and say, before I publish out these rules, is anything going to break for your application as we roll out microsegmentation? So we've seen a lot of success with our customers in going through with this approach once you have the data at hand to show it back to them. All right, so here I'm going to go back over, and here are my firewall rules that I'm about to publish, and then from here I'm all ready to start off with my microsegment. So what we've resulted here is a list of distributed firewall rules. But what does distributed firewalling actually mean? Right? So in the past, we've always had we send all this traffic over to a centralized perimeter-based firewall, and it's part of the job of my network team to actually start to connect those over and funnel my VLANs through it. Right? With distributed firewalling, we've actually taken advantage of a kernel module located within each hypervisor and actually moved all the packet inspection functionality over into each hypervisor. And this basically delivers for us line rate performance, since we're no longer funneling all that traffic through that perimeter device. Right? So that's from a platform perspective. If we look at it from a manageability perspective, we also take in all the goodness of integration with vCenter, so we can actually start to write our firewall rules based upon VC objects, such as my virtual machine names, VMs that have a tag of web app or DB, or based upon, let's say, the vCenter cluster it's sitting in, or vCenter resource pools. Anything in which you are logically grouping any of your applications in preparation for microsegmentation. Right? We can also integrate with Active Directory so that we can automatically detect the identity of who is logging into a machine and actually create and dynamically change my firewall rules based upon the identity of the user logging in. Right? Last and foremost, we actually also have the operations and monitoring capabilities for firewalling. So you can see exactly who created the rule, who changed the rule, making sure all those rules got published, as well as spoof guard to ensure that no one's spoofing any of your IP addresses. So this actually makes it a lot easier to manage at better performance. In addition to firewalling, we also have third-party integration with third-party next-generation firewalls, as well as IPS, IDS, and third-party guest introspection tools like antivirus, vulnerability management, file integrity monitoring. So all of these can actually start to fold into how you actually define your policy up front and consistently apply it to the workloads that you want to protect. So by separating these two things out, you get a very consistent, repeatable, programmatic process for automating how your rules get propagated out to your workloads. Right? In terms of our security group criteria, now instead of identifying things by IP address, you can actually start to create a group and dynamically say anything that matches a VM name with a prefix of web, automatically add it to this group. Anything that has been tagged with suspicious workload, or I want to quarantine that, you can start to automate some of those workflows. Let's take a look beneath the covers into how some of these things work between distributed firewalling, as well as when I have a third-party service inserted into the flow. So any traffic that leaves our virtual machine, we inspect it at the VNIC level before it ever hits any of your network switches. We actually, if the action is set to permit, we'll go ahead and forward the traffic. We'll also, if we detect a criteria for doing further inspection using a third-party service, we'll then steer that traffic over to that third-party service VM that is located on the exact same host. And if that's all right, they'll do their further processing before it's sent to the correct destination. Now, we have a broad ecosystem of security partners that have integrated with us from a guest introspection, network introspection point of view, as well as for better operations and visibility on top of this. So we do encourage you to go to our solutions exchange floor to actually see any of the further demos with all these integrations. So with that, I'll hand it back over to Nick.
Thank you much. So one of the other pillars that you saw in the use cases that Catherine mentioned earlier, she focused on the security use case. The next one that I wanted to spend a few minutes on was the automation use case. So we're seeing a lot of customers adopt NSX because of the automation capabilities and really the ability that the platform provides to automate your network, right? Or automate network constructs, I should say more specifically. So this is a build slide. I'm just going to build it out real quick, but this is kind of the nirvana that a lot of customers come to us and ask or are looking to try to build in their own environments. So what we're essentially saying here is, pardon me, we have our NSX components, some of which we've talked about in the previous architecture slides. Leveraging some sort of CMP or what we call a cloud management platform. Now, Catherine and I are good corporate citizens. In the demo today, we're going to show you VMware's CMP tool or orchestration and automation tool that fits under the vRealize suite. But we'll talk a little bit later about how you can use, homegrown tools, third-party tools. There's a bunch of tools that fit into that center category that we don't have time to show all of them today. And basically, the combination of those two, the NSX components and the leveraging of a cloud management platform, basically give you this idea of these on-demand application deliveries, right? Everyone for years has been trying to build this concept of some sort of self-service portal where basically, a user can go in, say, I want to provision this application, click a few buttons, click the Staples Easy button, and in a couple minutes they basically are presented with a big green checkbox and a thumbs up that says, here's your IP address, your application's been provisioned successfully, and you're off and running. So I would like to take a few moments and try to show you, like I said, a demo using VMware's tools, just exactly doing that capability. So as I mentioned earlier, this is a build slide. I'm going to build it out really quick. The idea here that a couple of the prerequisites are already done for us. So if I could draw a line in the center of this slide, at the top half of the slide has essentially already been pre-configured in our environment, right? If we go back to the previous section, we've deployed our managers, we've deployed our controllers, we've deployed our Edge Services Gateway, and that Edge Services Gateway in our example has actually been configured with BGP, and it's doing BGP pairing with the upstream physical network. What we're going to be automating in our demonstration is essentially the lower half of the slide and all those things that you see in the blue on the slide there, which is basically everything that makes up our actual application. So in this case, we have a web tier, an app tier, a database tier, respective VMs in each one of those tiers. Each one of those VMs has a corresponding firewall and associated security policies at that firewall level, and all of those logical switches that represent each one of those tiers of the application essentially all connect to that DLR or that distributed logical router. And again, that DLR is also essentially acting as the gateway, if you will, in and out of our virtual network. So I'm going to show you a demo. It's relatively quick. I'm trying to squeeze it into like 3 minutes. But what I want to say before we jump in, the idea here is with our vRealize product, an administrator in our demonstration has already gone in and defined the blueprint of the application. So someone in the organization, maybe even leveraged the tools that Catherine showed you already, has profiled and modeled the application, knows how it communicates between its tiers, knows how it communicates to the outside world or should communicate to the outside world, et cetera, and has essentially made the blueprint in vRealize automation. What you're going to see in the demo is essentially the cloud user's view, not necessarily the cloud admin's view, where the user essentially just logs in with their credentials and sees an application catalog, for lack of a better term, and is basically able to provision whatever applications have already been defined by the admin. So let's take a look. Like I said, we log into VRA with our user account, and as we log in, we're basically going to go into our catalog, and in our case, we only have 2 applications defined, but generally speaking, in some sort of production environment, you would have a lot of blueprints defined there. What we're basically going to do, and we're going to show a little bit later in the demonstration how we take advantage of one of our platform capabilities, which is our load balancer. I'm going to up the Nginx front end to 2 servers because load balancing isn't fun with only a single VM. So we say, okay, boom, we click okay, and now basically in the back end, we're starting to build all the machines. Not only are the actual machines being built, but all of the network objects, the network constructs within NSX are also being configured through the NSX API. So in a second here, we'll actually look at the list of everything that makes up that application, and we can watch each one of them basically be built in real time. So some of the Linux machines are being cloned from a Linux template. We're creating logical switches. There's a logical switch there called DB network, a logical switch there called app network, a logical switch there called web network. And we're basically going to provision or automate the provisioning, I should say more specifically, of all of those constructs that make up our application. But we're going to deploy that application and secure all of it with the corresponding networking security properties. So here we switch back over and we're just verifying what's going on from NSX. I know this goes very quick, and I know a lot of you said you weren't network admins, so I'm going to skip through the BGP peering and looking at actual IP addresses and all that kind of stuff because it may not be as pertinent to you. But what I do want to spend a minute on is actually looking at the load balancer configuration. So for anybody that's familiar with security services, you know you have to basically create a VIP pool. You create an IP address. The pool then creates members, or it contains members. In our case, we have 2 members there at the bottom. You can see the IP addresses, the actual virtual machines that are part of that load balancing pool. Right there, we're seeing that the 2 members are there, the 2 members are up. And basically, I switch back over to VRA after verifying the configuration in NSX, and we're just refreshing this page to see that all of our application components have been successfully deployed. Not only the actual machines themselves have been cloned and provisioned successfully, but all of the actual on-demand objects within NSX have also been created successfully. Now, like I said, the goal is to basically just get an IP address at the end of this entire process. That is our front-end IP address. We open up a web browser, we copy and paste in the IP address, and boom, we're now able to see our medical application. If I hit refresh a couple times in my Internet Explorer, you can actually see it being load balanced across those 2 front-end Nginx servers. So I know that was a lot in 2.5 minutes, and I know that demo goes relatively quickly, but the point is to show the automation capabilities of the platform. And all of that is done through the northbound APIs that the NSX manager exposes. So vRealize automation essentially takes advantage of our northbound APIs and is able to create all of those logical networking and security constructs on demand as you want to scale out your application, provision a new application, or take one application that's already existing in dev and now provision it for production. As I mentioned before, this sort of is a busy slide that summarizes a lot of the automation solutions that are out there that we have integration with from an NSX perspective. As I mentioned before, we showed vRealize automation, and again, we're VMware, so we're going to show some of our own products. But there's nothing stopping you from using other CMPs out in the industry. In fact, I know in EMEA, OpenStack is a pretty popular thing. You can use log into the Horizon dashboard and use OpenStack as your CMP and do the same exact thing you just saw through vRealize, but do it with OpenStack with NSX as the network from from the overlay network perspective. There's a couple other tools up there. Again, if you guys are more on the DevOpsy side of the house, if you write chef recipes or Ansible playbooks, etc. The whole point of this slide is to basically show the automation integration through that API layer that sits on top of our NSX manager. There was a lot of magic in that, so I wanted to explain a little bit more of some of the magic under the covers, so to speak. I want to spend a few minutes, again, just talking about the actual networking and how that, not only were we able to create logical switches and logical routers on demand, but once that application is provisioned and we've created all those logical constructs, how do we actually do packet forwarding? How do packets move in the environment? Nick, you said to me earlier that all the things that apply in a physical network still apply in a logical or virtual network. So I want to explain very quickly how some of those constructs, again, still apply in this NSX overlay. The first thing here is basically just connecting machines to a logical switch. So anybody who's followed the sort of historical path of ESX knows, in the 3.0, 3.5 days, we used to have a vSwitch. The vSwitch was confined to basically a single ESX node. Then around 3.5 or 4.0, we came up with this idea of a distributed virtual switch or virtual distributed switch. I've seen it represented both ways, but basically a switching component that it doesn't represent just a physical single ESX node. It's essentially stretched across multiple nodes inside your vSphere environment. That's what we're showing here as that vSphere distributed switch. So one logical switch that is essentially stretched across multiple ESX nodes in your cluster, and then they have uplink port groups that essentially connect into your physical network, right? The machines then attached to that logical switch. In this example, we have 3 virtual machines with different IP addresses attaching to logical switch 5001. In terms of actual packet forwarding, we build what we call overlay networks in NSX. There's a number of different overlay standards and specs, but the one that we use in NSXV today is called VXLAN. It's essentially a tunneling protocol that allows us to tunnel traffic from what we call endpoint to another endpoint. The actual technical term is VTEP, so VXLAN tunnel endpoint. Every ESX node essentially becomes a VTEP, and we basically say host A is VTEP A, if you will, and host B is VTEP B, and we're basically building a logical network that connects those 2 hosts together and allows us to do packet forwarding. The analogy I like to make, if you're unfamiliar, and I know a lot of you didn't raise your hand when I asked if you were networking folks, it's very similar if you've ever worked from home. It's almost like doing VPN, right? You have a VPN concentrator in your corporate office. You have a VPN client on your laptop, and you're basically building an overlay network that connects you into your company's corporate resources. Similarly, that's kind of what we're doing here, although VXLAN is much different than VPN. This is just a build slide to show you, again, what we're basically saying here from an encapsulation perspective is we basically take the Ethernet frame, we encapsulate it in a VXLAN header, we send it on the wire across the tunnel, if you will, and obviously on the opposite end, on the other VTEP, we then basically strip off all the VXLAN header information, and we're left with the original L2 frame that originated from our first host. So host B communicates through the physical network over our virtual overlay to host B, host A communicates to host B, and once it ingresses into host B, it essentially leaves the VXLAN tunnel, if you will. We strip off all the VXLAN information, and we're left with our original frame. The last piece from a switching and routing perspective is obviously the routing component. So this is just a visual representation of that logical router. Again, that logical router, that blue diagram that you see in the middle, is essentially the place that aggregates all of our logical switches. So here we have potentially a web logical switch, an app logical switch, and there could be, although it's not depicted there, a database logical switch if we're talking about the demonstration we just did with the medical app. And all of those have VMs connected to them, and each one of those logical switches essentially uplink into that router. So again, I know if you're at all familiar with how traditional networks today and the whole idea of layer 2 and layer 3, and traditionally switching is done at layer 2 and routing is done at layer 3, all of those same concepts that exist in traditional networks today still apply in this virtual network under NSX, and this is how all of those concepts get tied together. So earlier I mentioned that ESG, or that Edge Services Gateway, actually is comprised of multiple services. It's not just a gateway in and out of the world. So I wanted to spend, or in and out of the virtual world, I wanted to spend a few minutes here just talking about some of the additional functionality or additional features that those Edge Services Gateways can support. One of them is the load balancer. So in my quick demo, and I know it may have been hard to see with the time, what we've done is basically leveraged a platform capability within NSX, or our ingress load balancer, to basically say for our 2 web VMs that are in our load balancing pool, if any traffic, and in our case it was HTTP traffic, if HTTP traffic ingresses into our ESG, that traffic will be load balanced between the 2 members of our load balancing pool. So it's important to note that while we do often talk about traditional networking and security functions, NSX does support additional functions or other network features like load balancing, and the example you saw in the automation demo as well as this slide are basically just articulating the fact that we support ingress load balancing for HTTP traffic native within the platform, as well as integrating with other load balancers, as Catherine mentioned earlier, in terms of ecosystem. This is the last slide I just wanted to touch upon in terms of the actual services gateway itself, or the ESG. That particular virtual machine, as I mentioned, can be a router. It supports the aggregation of logical switches, as we already talked about. We also talked a little bit about the load balancing functionality, but that edge has a laundry list of features that it supports. So this is just a slide to give you an idea of what some of the more primary ones that customer uses those edge services gateways for. Firewall services, load balancing services. We actually support VPN services in the platform as well. So if you're doing some sort of multi-site or data center A, data center B designs, we have the ability to basically build VPN tunnels between NSX nodes in each site, et cetera, as well as things like IPAM, IP address management, DHCP, DNS services. Again, things you would typically think as of networking services, because we are the networking and security platform for VMware, we need to support those in NSX as well. So that's a list of a number of things that the Edge Services Gateway supports. Speaking of the multi-site stuff, Catherine?
So regardless of how many sites that you might have, we always want to make sure that our virtual machines get the same network and security services, irregardless of where they might live. So with the NSX virtualization platform, we actually make this a reality. So by abstracting away the underlying hardware, this gives you that flexibility to say, well, I have a new data center project coming up. I want to change out the vendor, change out the network topology, do something slightly different in site A versus site B. Right? We can start to abstract that away while still not disrupting any of the VM connectivity pieces. And now the way that we do this is to ensure that we can start to introduce the network virtualization from a universal perspective. So we've introduced these concepts of a universal logical switch, a universal logical router, and universal firewall rules that actually follow the virtual machine no matter where it might go from site A to site B. Now, if we kind of look beneath the covers on how this works, we basically start off with our management plane. We register our NSX manager to vCenter, and this is a one-to-one mapping today. We designate one of these sites to be our primary site, and once we do that, that basically initiates this universal controller cluster that has visibility to all the various workloads, and that then designates the other sites as secondary sites. What this means is from a manageability perspective, you can go either through a UI or through the API, make configuration changes on the primary site, and that ensures that it gets propagated to your other sites as well. Now, you still have local control on each site perspective, but when you start to look at it from a universal logical switch, logical router and universal firewall perspective, you can make changes in one pane of glass and have that consistently replicated and synchronized to your other sites. This means that if I've defined this is how my WordPress application should be micro-segmented, and it's consistent in site A, if I move those workloads to site B, it will continue to have that same set of firewall rules applied to it. The same set of firewall state moves over as it's vMotioned across on that logical switch. That provides you a lot more of that flexibility. Now, even though we've kind of expanded out our boundaries to multiple sites, we still want to make sure that it's not only easy for you to configure and push out those changes, but also needs to be easy to monitor and troubleshoot as well. So, Nick, can you guys show me a little bit about some of the tools or maybe some demos on how we can get visibility across these multiple sites?
Absolutely. As Catherine mentioned, the question that often comes up after everyone says, hey, this is really cool, some cool demos, I understand the product a little bit better, is how would we actually operate / troubleshoot this if heaven forbid, something actually goes wrong? There's other sessions obviously geared for 60 minutes of this, so I'm going to try to do what I can in a couple minutes and explain what we can do with some of the native platform tools as well as some of the other tools that are available in the VMware family to solve this challenge, or to address, I should say, customer concerns around sort of operations and troubleshooting. So I have a demo put together. It's like, again, another about 3-minute video. The one we're going to highlight in terms of actual platform capabilities, as you can see, there's a lot of things in there. I talked earlier about central CLI. We can do things with like NetFlow and IPFix data. And again, if you're not a network operator or admin, that stuff may not mean as much to you. But these are traditional tools that any network or network admin or operator is going to expect, because that's what they get with their physical switch. So if they're going to move or migrate to this logical or virtual environment or virtual network, they're going to expect a lot of the tooling to be there. The one I want to highlight that's native within NSX is called TraceFlow, and then we're going to talk a little bit about another tool that we call Network Insight. And you know, without further ado, let's just get into the demo. So Network NSX TraceFlow is essentially this idea of taking network traffic and injecting certain types of traffic into the actual network, the virtual network, so, you know, various packet types, basically to test reachability. So again, if anybody is familiar with traceroute as an example, I look at this as a very modernized version of traceroute, right? Basically what it's saying is I want to inject a particular packet type into a topology with a source A and a destination B. The difference is that we collect everything along the way. So what this is showing very quickly is that we actually have a firewall rule in our DFW firewall rule table that is preventing the traffic from reaching from A to B. In our case, A is app server A and B is database server B. So really quickly, we're able to diagnose that with the information that TraceFlow gathers. That's a tool native within NSX. This is a little demo of actual Network Insight. The value prop of Network Insight is it combines the visibility of virtual networking with physical networking. So we constantly get asked, great, you've provided all these tools for the virtual network, but what if all my VMs cross a physical network? How do I correlate data between virtual and physical? And that's exactly what Network Insight does. So what you can see here is basically, they call it the pathing feature. And what it's done is it's taken that same network map, but what I'm showing here is from DB admin to prod DB as an example, just 2 VMs in my topology. I can see hop by hop not only the actual virtual network characteristics, I can look at the UCS blade the ESX node sits on, the VM sits on, but then as I move out of the physical node, I see the virtual or the physical network as well. So that first hop right there, that physical VRF is actually a Cisco Nexus 7000, right? And I can see very quickly it's a Nexus 7000 and there's its routing table. It has a particular version of NXOS running on it. The next one there is a Palo Alto Networks firewall. So I can get all the information from PAN as well. And these are physical nodes in my path, not just virtual nodes. So this is one thing that differentiates VRNI or vRealize Network Insight compared to the tools that are native within NSX. As we all know from a networking perspective, the path that we take back can often be different than the path that the frame took going to its destination. So with a quick button flip there, I clicked on a button in the upper right hand side, and basically what it did is it drew the path in the reverse from DB2 to DB admin 1. And the path is slightly different, and basically I could go back and look at the same attributes hop by hop from this tool, again, allowing operators and administrators one place to go to be able to trace frames and troubleshoot frame and drops and counters and buffer overruns and those sort of things from, you know, again, one graphical representation or one UI combining both physical and virtual networking. So I know that slide was, or excuse me, the video there was pretty quick, but hopefully that makes sense and you get an idea of the level of information that Network Insight can provide both from the physical network as well as the virtual network. Catherine, you want to bring us home?
Sure. So basically what we've kind of walked you through was 3 major use cases around security, automation, and application continuity, and then shown you a little bit about the operations and monitoring and troubleshooting tools around this. So as you start to look at investing into a network virtualization platform, make sure that you're looking for something with an open ecosystem. We have been developing these integrations across the compute infrastructure, network infrastructure, the application services, the security services, so that you still have that flexibility to choose best of breed vendors that work for you. And now you can rest assured that they're all integrated as a tight solution with the network virtualization platform. So again, we encourage you to take a look on our solution exchange floor, look at some of these demos on some of these integrations. Now, as complicated as that might seem, of all these different things weaving together, we do have reference architectures that have taken a lot of the learnings from our multiple customers and put a really easy to get started type guide of how you should design your infrastructure for these various use cases around security, automation, and application continuity. So this is a great resource to start off with. We also have multiple sessions at VMworld this week that kind of go a little bit deeper into each one of these design considerations. So as you're starting to look at this with the recent announcements at VMworld of how we're taking NSX and helping you with your digital transformation journey, taking you into an era of having additional cloud services, start with something that's urgent, something that you're looking at maybe from a security point of view. Start and identify a key project, whether it's an automation project, a security microsegmentation project, or maybe you're looking at a full cloud rollout. Each one of these, no matter where you start, NSX is that core platform. As long as you invest in the training, as you've come to this session today, it's very easy to get started and slowly expand out to the various use cases. And that one platform can take you out over into the multi-cloud infrastructure. So I want to thank you for your time. Nick and I will be up front if you guys have any questions on how to get started or where to look next. Thank you so much for your participation.
Thank you, guys.